All right, let's do some Punnett squares. Alright, so remember, Punnett squares is what this looks like for your class. It's a dihybrid cross. That means it's two traits we're looking at. So it's going to be not just a little simple 4 squares, you have 16. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 squares. It's going to be a 4 by 4. Alright, so this is your Punnett square. Level 1 was how to set it up. So before we learn how to set it up, let's refresh our memories and understand the terminology. So this is our genotypes, like the genes, what they look like. We have to learn again about heterozygous, which is big A, little a, when you have a dominant and a recessive. Then we have homozygous dominant, which is big A, are two dominant alleles. And then we also have homozygous recessive, which are going to be two little a, are two recessive alleles. So remember, heterozygous is going to be dominant and recessive, homozygous dominant, big A, two dominant alleles, and then homozygous recessive is two recessive alleles, or two undercase. Alright, so the whole purpose of this dihybrid cross is to figure out the offspring's possible outcomes, and it's genotype and phenotype. But to do that, we have to set up the Punnett square. So let's just say parent 1 gene contribution will be up, parent 2 will be on the side. So we have to fill out these boxes. Remember, there's going to be 2 letters for each of those boxes. So how do we get those 2-letter combinations if we have these 2 traits from the parents? So parent 1, we have big B, little a. So it's going to be homozygous dominant for this trait and homozygous dominant for that trait. Let's just say B is for, I don't know, brown hair color. And then A is going to be for, like, green eyes. So big A is dominant for green eyes. Brown is going to be dominant for, big B is going to be dominant for brown color. All right, so remember how we need at least 2 letters in each of these 4 boxes. So we have the 4 spaces here. How to figure that out is how we FOIL. So B and A, big B, big A for the first one. Big B, big A for the second one. And then you do your FOIL. I remember factoring out. Big B, A, another one again. Big B, big A. So it looks like for the top portion, they're all going to be big B, big A, big B, big A, big B, big A, big B, big A. Alright, so for parent 2, we have big B, little a. So heterozygous for brown, and then it's going to be homozygous recessive for the green eyes. So let's say if it's going to be recessive, so recessive is going to be for blue eyes. So little a is going to be blue eyes. And then because B is dominant, it's going to show up over the recessive one, so this is still going to be brown. Alright, so same thing again to figure out what goes where. We have to factor it out. So the first one and the first one, so big B, little a, first and last, big B, little a, and then we do the last one, so little b, little a, and then little b, little a. So that's what we'll put on the side over here. Big B, little a, big B, little a, little b, little a, little b, little a. Alright, so this whole step setting up was for like a level 1. For level 2, it was filling in the Punnett square. So remember, when you fill in the Punnett square, you just basically drag and drop everything. So we'll drag all the B's down. So B, 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 and then it's like, was it that one game, Battleship. So you have to do your XY coordinates. So big B, and we gotta drag the A now. So big A, big A, big A, big A. So all of those are there, and then go from the side too. So it's gonna be big B here because we're transferring this one all over. So big B, little a, another big B, little a, big B, little a, big B, little a. Because we're moving that one to this whole row down for that whole column. So that means for this particular one, it's going to be big B, little a, or big A, little a. So that's the genotype of this offspring, because every box was an offspring. So that's what this box's offspring is going to be. Big B, homozygous dominant for the brown color, and then it's going to be heterozygous for the eye color. So I'm going to fast forward and I'm going to follow these out. All right, here you guys, time skip. I filled it out. So like I said, you just basically drag and drop everything. So for big B, little a, or big B, big A for that whole column, that's that contribution. For the column, you just drag and drop everything. And then for the rows, same deal, drag and drop everything. So I filled it out right here. And then the purpose of a Punnett square is to figure out the possibility, the percent possibility of the outcomes of all the offspring. So you do this ahead of time before you actually make the babies. So see what your chances are to have whatever trait and whatever trait. So for our example, remember it was big B was dominant for brown hair color and big A was dominant for green eye color. So let's figure out the genotypical or genotype probability in our offspring. So remember, not normally, you could always have a possibility of 12 different outcomes. You just got to count out the differences. So for this instance, we only had 2 possible outcomes. It could either be big B, big A, little a, or big B, big A, little a. So those are the only 2 outcomes we have for our given Punnett square right now. So pretty much it's right now, if you count all of them, which you could do later, but I counted all of them, it's already going to be a 50-50 split. So half of them are going to be big B, big A, little a, and then the other half is going to be big B, big A, little a. So to figure that out, you literally just count how many in the boxes there are of each one, and then you erase them, tally them, however you want to mark that you already counted them so you don't lose spot of all the different ones you have. So that's the genotypical possibility of the offspring for the only 2 ones that we have available for based on our Punnett square or these 2. It's 50-50% chance. So this right now is a level 3, actually doing the math to figure it out, or just counting them essentially. So for our phenotype, we actually have 2 outcomes. Not 2 outcomes. We only actually have 1 outcome technically, because if we look right here, look, we said big B. Any big B's they have, it's going to be dominant, so it's going to show up over the recessive trait for brown hair. So both of our instances have brown hair. So we have brown hair, and then also we have green eyes. That's going to be little a, or big A is dominant over little a, so they're all going to have green eyes. So we only have 1 technically outcome. Like usually one possibility for the phenotype, what it physically looks like, not the genotype, but what it physically looks like. So we only have 1. It's gonna be brown hair, green eyes. It's gonna be 100%. They're all gonna be looking the same. So they have different genotypes, but because of the dominance of the brown hair and the dominance of the green eyes, they're all gonna look the same, as 100% of the 16 offspring will have a chance of being brown hair with green eyes. So that's pretty much it, the quick recap. I'll put some practice questions for you guys to do, and then whenever you feel comfortable enough, I have the test ready for you to do. So if you want to get your grades up, you get your grades up. If you're happy and fine with that, that's fine. Continue doing the work though, because your grades will be affected by the work you do on e-learning. All right, have fun.